Alright everyone, so today we will be making a slope chart in R. Basically, slope charts are pretty useful for, comparing two different values at two different points in time, or multiple values over two different points in time. So, kind of similar to what you can do with a bar plot, or, multiple scatter plots looking at trend lines, but for our slope chart we will only be using 2 years, so essentially 2 slices in time, and we're going to be looking at the number of employees hired for different departments in a company, but for 2007 and 2017. So I'm just going to run the data real quick. Oh, wait, nope, can't run the data. Step 1, always import dataset, unless, your dataset's already imported. So we're going to go over here, go to import Excel data, browse. I made a specific dataset to go along with this, and so our little data preview gives us the department, so we have sales, marketing, etc. And 2007 and 2017. I added 2012 to attempt to make 3 points, but we'll get into that momentarily. So when you actually add the data to it, nope, this is not how the chart's supposed to appear. So let's run it again. Get a fresh output of a chart. Takes a little while to make it happen, but now that it's up and running, bam! So we have our slope chart. So we have employees hired, the year, which year it is, and each of the individual departments. And it's actually kind of color-coded depending on whether it's an increase or a decrease. So running through the code, you have your library, which allows you to use a ggplot2, which is basically a way to generate plots. Scales is a generic plot scaling method, so it's just a way to make sure that your plot fits inside the little window that you have here. You can shrink this. Read Excel is pretty common. That's, I don't know, I think something to do with reading Excel. That sounds about right. So I'm going to take the data set that I made, IP data, and just push it into the simple data command. So we have call names, which is short for column names, which is these right here, as well as these, so the 2007, 2017, and these. So the C is the combined values into a vector or list. So basically we're making this and pushing it into column names to create these right here. And we're going to move on to specify what goes where. So our left label, we want to paste, go into the data set and grab the department label, and go and use the data from 2007 and separate it using a space, or using a comma. So basically this sets up these actual individual spots down here. So we have our sales, which is the department that it's under, the year that it's in, the year that it's under, so 2007, and 2017 is the next line for our right label, and then separate it by a comma between bop and bop. So that's what that little green area is right there, that comma, thrown it in there. So the right label is pretty much that same thing. It does this portion here, so accounting, comma, 16 people hired in accounting for 2017. And then you have data, $class, so going into our data set, there is no class variable in our data set. We're actually creating that. Okay. We're actually kind of creating that and pushing some information into that. So if else is basically our if then statements, but it's what's coloring these lines here. So if else, you can put if the data for 2017 minus 2007 is greater than 0, make it red. So if basically the trend is negative, make it red. Else, make it green. So this is a different way to do an if-then statement for slope charts. So as you can see, for all the ones where it increases, it's green, but if it decreases, it's red. And that's what this line does, basically. It tells it what colors to be. The actual creating it in the chart is down here, but we'll get to that momentarily. So the P is essentially our plot. We're going to want to push all this stuff into our plots. And so a bunch of things are being pushed into P repeatedly. So we're just adding parts into our plot over and over and over and over and over again. So ggplot, which is the plot creator essentially of this data, plus geometric segment. So this basically allows us to create a or point out different portions of our graph. And AES is aesthetic, so for x1, which is this row right here, and x2, we're going to specify this is the end, y equals 2007, y end 2017, so these are from our y column, and color equals class. So if we were to essentially get rid of this section right here, the lines would appear all black. So it's basically going back and calling the class variable that we created. Size 0.75 basically determines the thickness of these lines, and show legend false. Everything's kind of clear in the chart, so we didn't really need a legend. So now we're going to add that onto geometric vertical line, which creates this dotted line right here. So we're going to specify it's for the x-intercept number 1 that we referenced up here, and we're going to make it dash. We could have made it solid, but solid line makes it almost confusing with the y-axis. We don't want that, and we want it in a 0.1 size. So we don't want it too thick, we don't want it too thin. And then we do the same thing for x-intercept 2, which is this one right here. And scale color manual is the part that I was referencing that actually goes back into class and grabs the color shades that we want. So we specified green and red, but we can modify the actual representative colors that are created. So if we wanted lighter shades or darker shades, a specific color of green or red, we could put in a hex code for it. So moving on, labels, x equals, x equals year. I don't know why that's appearing. I erased it, but it's still appearing. Originally, there wasn't supposed to be anything in the x label because it's kind of obvious what our x-axis is, but somehow it's still there. Maybe if we get rid of this space here and run it, we can get rid of this little section here. We'll see. But the Y label is our employees hired for the 2 years. It still appears. That's really weird. I don't know how to get rid of that because that is definitely where it's coming from, but that was from when I was playing around with the data, figuring out what everything does. So that's interesting. This is kind of broken then. X limitation is how far across this goes. 0 to 3, so it starts at 0 and ends at a value of 3. So I actually made the tick marks visible just so you could see. So this would be 0 right here. This would be 1, 2, and 3. Originally, from the source code that I got, it was at like 0.5 and 2.5, and so part of management was cut off, and management and accounting's values were cut off. So expanding that gives you space to have super long variable names and stuff. And then we're doing our y limitation a little bit differently. Our y limitation, we're going to start it at 0, and then we're not going to put a specific end cap value. We could, but if you just want to make it data dependent, you just do it a little bit higher than your maximum data. So 1.1 times whatever your maximum value for this and this is. So not combining them, but for example, if 2007 had a value of like 216, it would do 1.1 times 216 to set the maximum of the y-axis. Now we're moving on to pushing more p's into p's plus geom text into p's plus p's plus p's. So we're pushing more stuff into our plot to make more specifications. And so basically this geom text adds text directly to the plot. So this is what puts the labels on the plot. Up here creates the labels. This actually throws it into our plot. So our left label will be our y data our y will be the data from the 2007 variable, and our x will equal all the values, the n row of that data. And the horizontal justification is basically just a way to make sure that these don't overlap on top of these. So we have 1.1, which will put it a little bit above the first tick mark, and then negative 0.1, which will put it a bit to the left of the next tick mark. And size 3.5 is the font size of that. And we're going to do the same thing for 2017 right there. And so X represents the second one. That 2 is in reference to that, and that 2 just pointing out where it's supposed to be. So we're also going to do the labels for the top up here to make sure that they match up. So the 2007 goes up there. X equals 1, and then y equals 1.1, just so that it stays above the maximum values of whatever the data set is. So it's pretty much just putting it above where our data lies, rather than having it at a specific point. It's at a point above the maximum value of the data. And the last portion pushes certain elements into the actual plot, making them visible or invisible. So panel background equals element blank. Basically, this panel would normally come in 2 sections. So this part is the main plot, and then the background. You can make those different colors and have different things, but we just want plain white. Axis text, getting rid of this will get rid of year and employees hired. And, we kind of want that. It's kind of important. And plot margin is basically how much space this takes up inside our little window. And so units, you have it in centimeters. So when you export this, it comes out a specific size. But these adjust in the bottom, left, top, and right order respectively, and so adjusting these will adjust the parameters of your graph. Now, real quick, I mentioned that I'd made a 2012 data section to see if I could do 2007, 2012, 2017, but the way the code is set up, especially this left label, right label up here, there's no real code for center label or middle label or anything like that that would allow me to tell it, hey, I want 3 columns, and specifying that I want to put a 3rd column in here. And so I played around with it a bit. There's actually a whole separate code for if you want to do a slope chart with more than just 2 data points. But that's how you make a slope chart in R. See you around.